Okay, today we're going to be talking about graphing linear equations. And it would be really helpful, I guess, first to talk about what is a linear equation. What does that entail? So let's talk about some of the qualifications for a linear equation. First of all, it has an x value and sometimes a y value. That being said, x and y are never multiplied together. Neither one of x or y is used as a denominator. And it cannot be raised to exponent. So that's going to look very different from the quadratic stuff. Okay, so those are linear equations if they meet those criteria. We also want to talk about slope and what the slope of a line is. And so that will come when we're talking about putting things in slope-intercept form. There's a bunch of different forms in which we can write equations. Slope-intercept form is the first one, and that means I have some y equal to m, the slope, times my x plus b. And b is going to be the y-intercept. What does y-intercept mean? Well, that's just where the line crosses the y-axis. I'm sorry, the y-axis, yeah. Okay, and slope, if you remember from last year, or even if you don't, is the rate of change. Okay, and we'll talk more about that. So slope-intercept form is definitely one way to write an equation. In fact, it'll be the most popular way we're going to write equations. But we also need to look at what standard form is. And that means I have sum a times x plus sum b times y equal to c, where a and b are some kind of coefficients, and c is my constant. Okay, again, we're not going to use standard form all that much, although you will see things in standard form and then have to translate them to slope-intercept form. So let's actually practice going from slope-intercept form to standard form. So that means I'm going to have an equation y equals negative 3x plus 4. This is in slope-intercept form because I have some slope, m, negative 3, and some y-intercept, or that plus b, that plus 4. Okay? And I want to get it into the standard form, which is this. So if you notice, in standard form, x and y are on the same side of the equation. So I need to add 3x on both sides. So that should give me 3x plus y equal to 4. And I now have it in standard form. Is that linear? Yes, it has an x and a y. The x and y are not multiplied together. Neither one is a denominator. They're not raised to exponents. So yes, this is linear. And now this part is in standard form. So let's try another one of these types of problems. So let's say x squared minus 4 is equal to y. Is that even linear? No, because it's raised to an exponent, so it is not linear. Okay? The next one, 1/3 y equals -1. Is that linear? And then is that in standard form? Okay, let's go ahead and talk about graphing, because that's what the title of this was called. And, you know, obviously it would be very helpful if I can graph things so I can get good answers. So when we're graphing things, we always want things, or typically we really want things, if at all possible, we want things in slope-intercept form. So I have, that is the y equals mx plus b. Okay, so let's say for this first example, I have y equals 1x plus 4. And again, that 1 is sometimes there, sometimes not there. It's an understood kind of thing. Okay, so let's see if I can get graph paper on this. So I guess the answer is kind of graph paper. So I'm going to draw my coordinate plane. With all 4 quadrants. And I want to plot these points that I have from this equation. Well, what points do I know I can start with? My y-intercept, it's where it crosses the, which axis? Yeah, the y-axis, which is this up and down one. This is the y, this is the x. So my first step is going to be to plot the y-intercept. So my y-intercept, or the b, my y-intercept is 4, so I'm going to go up 1, 2, 3, 4 on my graph, and I'm going to stick my point there. And that's my y-intercept. Then I know that slope is rise over run. Okay? So if my slope is m is 1, it means that is 1 over 1. So I go up 1 over 1. So let's say these are my points on the x. So I go up 1 over 1. Up 1 over 1. Up 1 over 1. Up 1 over 1. Okay? Similarly, because this is the positive quadrant where it's positive, positive, I could also go down towards my negative quadrant, or it's another positive quadrant, but it's negative, negative. Remember, a negative times a negative, or a negative divided by a negative is a positive, so that'll work. So I can go down 1 over 1, down 1 over 1, down 1 over 1, and so on like that. Just so I have enough points to draw a line through these things. And again, my drawing is not super perfect, and that's okay. So some of these points look like they're on the line and some of them don't. But this is my line, and when I'm done, I'm going to label that line. And how will I label it? Well, with the equation I started with, y equals x plus 4. The big qualifier here is how many points do I actually need to make a line? I need at least 3 points to make a line. Uh-oh. So let's start the second example. I have y equals 2/5 x minus 2. So what's my y-intercept? Good, -2. And my slope is 2/5. Good. So I'm going to start by graphing that -2, my y-intercept. That was my first step. And it's here. And then I see my slope is rise 2, run 5. So I'm going to go up 2, 1, 2, over 5. And there's my next point. Similarly, I can go down to left 5. So 1, 2, over 5. The only reason I did that is because my coordinate plane, while it goes on forever, my paper does not. So that's going to be hard. And I do need at least 3 points to make my line. Holy moly. So let's pretend that goes through this point as well, because I just did not start it in the right spot. And the last thing I do here is to label it. So y equals 2/5 x minus 2. I can also make a graph from a table. So if you're graphing from a table, I'm going to want to make a t-chart of my x and y values, and they will either give them to you or they will have you create one based on the formula. I'm just going to start by giving you one. So I have 0, -24, 3, -18, 6, -12, 9, -6, 12, 0. And what I can do is I can go ahead and start plotting those points. So let's draw them on a graph. And I'm counting by 6s on the y, and on the x, I should probably count by 3s because that's what it gives me in the problem. Okay, and I'm going to start matching those points. So I have when x is 0, y is -24. That's down here. When x is 3, y is -18. When x is 6, y is -12. When x is 9, y is -6. And when x is 12, y is 0. And I can go ahead and draw my line through those given points. And again, not the best drawer ever here. That's okay. Things I can note about this graph, I can note the y-intercept and the x-intercept. So the y-intercept is where it crosses the y. And it crosses when x is 0 and y is -24. And I want both points of that coordinate point, both values, the x and y values. The x-intercept is where it crosses the x-axis, and that crosses at 12, 0. So those points are important. So let's say they give me an equation, y equals 3, and I want to go ahead and set up a chart for that. So I'm going to have x values and y values. When x is 1, y is 3. When x is 2, y is 3. When x is 3, y is 3, because y is always going to be equal to 3. That's one of those ones where it's a little crazy to think about. So let's go ahead and draw on a graph. So here's my points, 1, 2, or this is 3, I guess is what I need, 1, 2, 3. I can go down as far as I need to. When x is 1, y is 3. When x is 2, y is 3. When x is 3, y is 3. And it's going to be 3 forever. So what I know about this is, well, the y-intercept is going to be 0, 3. I also know that the slope is 0. Why? Well, because if I was a little skier skiing across this land, we'll draw some nice little skis, you're going 0 miles per hour. It's straight, versus the other ones that looked like this or like this, I have some momentum to go down. Also remember that if I get a slope that is vertical, up and down, so here's my coordinate plane, and let's say I have a slope that looks like this. That is a no slope type problem. Because when I get to that and I'm skiing, I should say no. Okay? This is a negative slope. And this one is a positive slope. Okay?